All right. Hello, GraphQL Conf. Today we're going to be talking about a new proposal I've been championing for the past year called Client Controlled Nullability. And this is what a year of working group meetings looks like. Hi, I'm Alex. I'm an iOS developer at Yelp. I'm on our data and networking team, whose current charge is to transition the company from REST to GraphQL. I work on iOS tools, libraries, documentation, and educational resources to that end. I've been doing open source work on and off since I started as a software engineer, mostly doing work for the server-side Swift framework, Vapor. I'm particularly interested in the developer experience of the folks we support, so that'll be a recurring theme today. A quick word about the company I work for. Yelp produces mobile apps and websites that connect consumers to great local businesses and provides businesses the tools they need to thrive. The company is fairly large with more than 1,000 engineers. That kind of scale means that investments in tooling pays dividends that you wouldn't get at a smaller company. This presentation is about one of those investments. I'll plug some positions at the end, but we're hiring. So if the kind of work I'm talking about here sounds appealing to you, shoot me an email or come talk to me after the show. Early on, we recognized that nullable fields would be a problem for our developers. There are a few reasons a schema author might make a field nullable. For example, a user may or may not have a phone number, so for data modeling reasons, the phone number field is made nullable. However, many schemas adopt the policy of making most fields nullable for data preservation reasons, as the official GraphQL documentation recommends. In this illustration I've borrowed from Apollo's documentation, every field in the schema is non-nullable. If the address field resolves to null, then during the completion step of execution, the executor will search up the tree until it finds a nullable parent, and then that field will be set to null. In this case, every field is non-nullable, so the response data field itself is set to null. For many applications, this kind of data loss is undesirable. So keeping every field nullable allows for partial results, because if a nullable field resolves to null, the total number of fields lost is 1. However, this mechanic means that many fields are nullable that are never expected to resolve to null in the happy path during normal execution. We decided to more or less follow the best practices at Yelp, so most fields in our schema are null. This preference for nullability caused compile time problems for our developers working in typed languages like Kotlin, TypeScript, and Swift, which explicitly require null handling, and caused hidden problems for developers working in other languages like JavaScript and Python. It was very evident when we started running developer experience surveys with teams trialing GraphQL at Yelp. You can see some of their feedback here. That problem being that in order to safely deal with responses, every field must be individually null-checked. This is not a problem in our legacy REST services, where the existence of some fields could be guaranteed in a successful response. Our interim solution was to encourage developers to write wrapper types for every response that would handle unwrapping every field. But this was quite a lot of manual labor, and we very much did not want to force developers into a new system that was worse than the old system. If you do that, you start losing trust, and it's very hard to come back from that. Here's an example of one of those types that handles null checking. It's about 70 lines long, and I've chosen it as an illustration because it could reasonably fit in the slide. Some are longer, some are shorter, but we've got something like 70 of these across our iOS code bases, and we're really just beginning to do a company-wide rollout of GraphQL at Yelp. Other platforms are basically in similar situations, so obviously this wasn't sustainable. So this problem floated around our team sinks for a while. We evaluated a few different approaches to address the problem, including maintaining forks of Apollo's clients and code generation tools, but none of them were particularly attractive. And a language proposal kept surfacing as a possibility. My coworker Liz created a backlog Jira ticket for the concept in August of 2020, and the code snippet you see here would eventually serve as the basis for the proposal. The deciding factor came when we started talking to our counterparts at other companies. When we had a meetup with some folks at Netflix and they told us they were running into the same problem, that's when a language proposal became a legitimate contender. This wasn't something that we were facing alone. This was a problem that other companies with more resources were facing, and at Netflix they decided it was worth solving with a custom directive. We would later learn that the Relay team too had been quietly working on their @required directive that's now available to the public. That night after the meetup, I'd had a bit to drink and was feeling overconfident, enough to write the first draft of the proposal. Stefan and Young from Netflix hopped on board a few days later. The proposal was basically this. Folks writing GraphQL schemas are incapable of predicting every use case for the schema, and that's fine. Client developers working on features are in a better position to decide when a field is necessary for their feature to work. We will provide them syntax that they can use to indicate that a field is required. That's it. For example, I'm working on a profile page for a business, and I absolutely need the business's name in order for my feature to be coherent. Other fields I can do without, but I absolutely need my business's name. So I can throw an exclamation point after a field to indicate that it's required. The server will treat the field like it's non-nullable, and more important for our original use case, code generators are provided with enough information to generate non-nullable types for that field. So developers don't need to unwrap it by hand. In this example, we're applying the new syntax to the name field, and for those of you familiar with Swift, you can see at the bottom snippet the kind of code that code generators might produce, in which the name field is not optional. Additionally, if a feature evolves to no longer absolutely require the user's name in the future, I can alter the query I'm using to fetch data, and it won't be a massively breaking change like it would be to alter the nullability of the field in the schema. We'll be calling fields marked with an exclamation point required fields for the rest of the presentation. While that core of the proposal basically remains, folks in the working group introduced nuance almost immediately. Some of you in the audience might have thought of some of these problems already. Lee was the first person to suggest that the inverse of the required designator should exist, and that it should be represented by a question mark. The reasoning was that it completes the story of control and provides a guaranteed stopping point for null propagation. If we're using the existing null propagation, and provides a guaranteed stopping point for null propagation if we're using the existing null propagation rules. The feeling was that introducing the required designator without the inverse is like introducing throw without catch. Lee also surfaced that there are some use cases, like his own at Robinhood, where they're trying to balance developer experience and data preservation, and have opted to mark quite a few fields non-nullable. Because data preservation is so important to them, they have the opposite problem, where that sometimes they want to be able to halt null propagation rather than the inverse use case, which this proposal originally supported. Developers at Apollo indicated that many of their customers face problems around schema breaking, where the solution to developer experience gripes is to make a breaking change and swap a field from nullable to non-nullable or vice versa, which can be a labor-intensive process. Since there seemed to be a general consensus that the inverse of the required operator was a good addition to the proposal, it was accepted without a vote. For the rest of the presentation, fields marked with a question mark will be called optional fields. Developers from Apollo suggested early on that users would want to apply client-controlled nullability syntax to list elements, meaning developers would be given a way to say that they didn't want any null elements in lists. The possibility had been suggested earlier as well, but it was put off because neither Netflix nor Reilly's client-controlled nullability counterparts had the feature, and it hadn't been a problem yet for either of their use cases. However, there was enough interest during the community feedback sessions to adopt it into the proposal. Discussions around which specific syntax to use happened over the following months. This syntax, which we referred to as the bracket syntax during discussions, was selected for adoption by majority vote at the March 3rd, 2022 GraphQL Working Group meeting. 9 out of the 10 participants voted for this option. Here are a couple other options that were also considered by the working group. The folks that voted against the first option felt that it was unclear how it should be interpreted, whether operators should be applied from the outside in or inside out. And folks that voted against the second option felt that it read like a typecast and that the inclusion of the type placed an undue burden on client developers. Validation would fail if the type was incorrect and didn't provide much additional value beyond looking closer to the schema language syntax. There was one last big thing that the working group decided. Rather than required fields acting identically to non-nullable fields, they would differ slightly. Instead of using the standard null propagation rules that dictate that propagation ends at the first nullable parent, we decided that null should propagate to the nearest optional parent. The working group selected this behavior for adoption by majority vote at the March 3rd, 2022 GraphQL Working Group meeting. 7 out of 8 participants voted for this option. So take this query where the author has made name a required field and all fields are nullable in the schema. Prior to this change, if name resolved to null, then it would propagate to the nearest nullable field, which is owner. So owner is null in the response. And here's where business has been made optional. The response is still the same. But after this change, null propagation doesn't halt until it finds an optional field. And if there isn't one, the entire data field is lost. We talked about how this might be a foot gun, because forgetting to pair a required field with an optional field now means total data loss. But the working group believes that most operations are relatively small. And in addition, many popular clients opt to throw out entire responses in the case of any errors. So they've effectively been choosing the worst case scenario when given the option anyway. This is something we'll be keeping an eye on as we roll out, and we're hoping that adequate documentation and tooling will prevent folks from shooting themselves in the foot. With this new behavior, developers can keep tight control of null propagation by marking a field optional. You can see that propagation halted at the business field in this response, which is the one that is marked optional. This was a mechanic most requested by the folks at Meta working on Reilly, although I want to emphasize that the working group ultimately decided that it was best for everyone. Reilly wanted this behavior for a few reasons. During execution under other GraphQL use cases, fragments are merged and fields are resolved a single time. This causes issues for client control nullability because required fields and optional or nullable fields are different types and therefore cannot be merged. We've opted to place a tight validation restriction that, for now, that throws an error if a selection set contains the same field with different nullability, even if the fields are in different fragments. Through some clever trickery, Reilly prevents a facade of fragment isolation for its own @required directive that you can see there. If a field is null, rather than merging fragments and propagating null to sibling fields on selection sets that use that fragment, the most popular option, as chosen by 90% of Reilly users, is to have the request throw and utilize React's error boundaries so data is only lost within individual components and also individual fragments. It also has the option to do something closer to the standard null propagation, but that too is bound to a single fragment and it's significantly less popular. Client-controlled nullability, as it stood, would break the facade of fragment isolation and also cause problems for Reilly users given the heavy use of fragments and strict validation rules. Its Reilly equivalent was also unpopular, and we felt that it was important to take into account what user feedback we had on hand. Reilly likely won't be able to use client-controlled nullability at first, but Reilly's developers would like to be able to use it in the future. You'll hear more about how the Reilly team plans on accommodating for client-controlled nullability later today. The selected null propagation behavior preserves the possibility of Reilly and other similar clients using client-controlled nullability in the future. The popular throwing option that Reilly provides on the @required directive effectively allows developers to indicate if some field, required field is missing, throw out everything from this field to the fragment boundary, which is tighter client control than was provided by the initial iteration of this proposal. In that case, the server still had control over where null propagation halted, which fields in the schema said were nullable. This selected null propagation option is slightly closer to Reilly's most popular required option, @required directive option in that way. Additionally, with the initial iteration of the proposal, if users wanted to guarantee that all fields through multiple parents should be lost in the event that a field is null, they would need to mark each level of the field with an exclamation point, but the new null propagation behavior makes that sort of thing much easier. So here's where the proposal started, and here's where we ended up with all of the additional syntax and rules that were added. So if I've done my job, you're thinking to yourself, that's awesome. How can I use client-controlled nullability right now? And the answer is you can sort of use it, but the ecosystem is a tad fragmented at the moment. You can start preparing your iOS projects to use it with Apollo iOS 1.0.0 Alpha 4 and above. The Apollo team is working on the other platforms, but at Yelp we're piloting client-controlled nullability on with our iOS developers, so that's where we've focused our efforts. Code generation works great. There's a flag you enable when you're configuring your code generation build phase, and it works. Beautiful. If you're working on your own client or server that utilizes GraphQL.js, or you use GraphQL.js directly, then you can also start preparing for client-controlled nullability with GraphQL.js's Canary releases. I cannot emphasize enough that these are not stable. In fact, you should expect canary releases to break and take the necessary precautions. Similar to Apollo iOS, Client Controlled Nullability can be turned on with an experimental flag passed to the parsing function that you can see there. We've placed these under a flag because we've gotten the go-ahead from the working group to release Client Controlled Nullability before it completes the RFC process, so we can collect community feedback. So the code in these canary releases will eventually make it to a stable release, still under an experimental flag. Michael, the maintainer of Hot Chocolate C# client and server, has done a Client Controlled Nullability implementation as well, so that's another option if you want to give Client Controlled Nullability a try. The working group is still mulling over some of the details around error handling and null propagation, so there's definitely still time to provide input. If you got any, please swing by our discussions in the working group repo or show up to a working group meeting. Having the opportunity to work in open source for your job like I have over the past year is somewhat unusual, so I want to share what I learned and encourage folks to do similar projects. The way that we estimated this project was to look at other proposals and see how long it took to complete them. Our original estimate was 6 months, so we were a tad off the mark. I still think this was a good way to go about estimating, but we would have been more precise if we had all the information that we have now, namely that, one, being able to work full-time on the project would not necessarily make it go faster. Most of the people we've been communicating with are doing this work on a volunteer basis or as a minor part of their full-time job. You're not working with your coworkers. You can't dictate timelines. People get back to you when they want to get back to you. It sounds like a complaint, but it's not really. Open source projects are not companies, and you have to understand that there will be a mismatch anytime one party is doing full-time paid work and another is a volunteer. This partially explains why, besides being lovely folks and great open source stewards, working with the Apollo team on Apollo iOS was the smoothest part of the entire process. We didn't have that mismatch. Most of the work by volunteers understandably happens shortly before, after, and sometimes during working group meetings. So you have to really have about a week every month where you reliably have most folks' attention. It took us a bit, but we got into the cadence of things later on in the project. It really helped to get discussion started quickly as possible after working group meetings so folks could respond in their own time. It helped to work opportunistically when bottlenecks were unblocked, and to have a stream of normal tickets to work on whenever there wasn't anything that could be done for the proposal. Although it's taken a while, and it's going to take a bit more, most of the fears I had about how difficult this would be didn't really turn out to be true. As someone without an academic background, I don't have a degree, I was worried that I lacked the knowledge necessary to work on the project and be judged for it, but everybody has been extremely kind and helpful. As someone who's attempted to work on the Swift language before and gave up because it was far too difficult, I was worried the implementation would stop me in my tracks, or at least be the most difficult part of the whole project, but it hasn't been. Ivan and the rest of the GraphQL JS maintainers have done an excellent job and created an excellent code base. The tool they've chosen to work with is great, and iteration speeds are quick. So if you're thinking of attempting a similar project yourself and you've got time to kill, you'll need to be persistent, but don't let fears of difficulty stop you. Over many working group meetings, we've had many discussions about how different parts of the proposal would work, and something key I've learned that I've been able to turn around and apply at work are that polls are your friend. I've observed during discussions that people will typically speak up to present a new idea or disagree with an idea that's already been presented, but they won't speak up to second an idea unless they have something additional to add. Engineers like ourselves also have a tendency to explore pros and cons of every possible avenue, even those we don't particularly back. This can make the field look much more divided than it actually is. I mentioned vote counts for list syntax and null propagation a few slides back, which were nearly unanimous, so it might surprise you to learn that discussions around those in working group meetings prior were lengthy and quite vigorous. If you feel like discussions are going long and you need to move forward, run a poll. The results may surprise you. Working group meetings and GitHub threads unfortunately have their limitations. The ability to go into extended back and forth with folks doesn't really exist, and it's uncomfortable making a couple dozen people sit there while you suss out an idea for yourself. Walls of text aren't fun to read and exhausting to write and proofread. Some of the most productive conversations I had during the project fell outside the official channels with folks at Meta, Netflix, Apollo, and a few other community members. Like magic disagreements we'd have been having for weeks evaporated in a few hours. If you've been going in circles for a bit with the same folks, send them a calendar invite and give them a ring. Confront problems head on and with honesty. In addition to solving all the issues I mentioned, I think it really helps to humanize folks. As much as we might try, speaking in public forum is a bit of a performance, and being able to get past that and see folks behind the screen as humans with families and hobbies and jobs where managers are setting deadlines or open source maintainers with needy users, and being able to hear all that and say, yes, I understand and I can empathize, goes a really long way. A sizable number of people were involved in this project that I want to thank. Liz, Mark, and Wei at Yelp, Young at Square, and Stefan at Netflix all contributed to either the original written proposal or the first working group presentation. Liz had the original idea way back in August of 2020 and suggested the name Client Controlled Nullability and was invaluable in her mentorship and guidance when it came to navigating the community feedback process. Wei did the first implementation around the same time as a hackathon project. Mark and Young worked on getting the GraphQL JS implementation migrated to TypeScript and ready for public review. And they were also the first people to help me learn TypeScript and the toolchain around it. Jordan was a great sounding board, especially around Reilly's rather unique problems. Sahaj and Ivan both gave me guidance and code review on the GraphQL JS implementation, and Anthony and Hugh worked with me on the Apollo iOS integration. There were loads of other folks that provided feedback during the RFC process, and y'all were incredibly helpful. Yelp will be piloting client-controlled nullability once it's in a stable release, but we're looking for other companies and folks who are down to give it a shot and provide feedback. So please reach out to me if you intend to use client-controlled nullability, and I'll do what I can to help. Once again, I'm Alex Reilly. I work at Yelp. We're hiring, especially for folks that want to work on iOS infrastructure. Thank you, and are there any questions?